So that hello. I think I'm visible now. So my purpose of doing this streams so that I can let me switch off that bulb. Where are we? I'm saying that my purpose of doing this stream is so that I can replicate the interview situation where I have to speak while solving. So let's do it. So today's question is swim in the rising water. What we have, usually I think I will write on paper, or should I use this, or should I use notes? Let's try to use notes. First of all, we'll see what they given to us. Okay, so we are given an integer matrix grid where ij represent the grid ij. Okay, this is starts raining and water gradually rises over time. Okay, gradually over time. At time t, the water level is t, meaning any cell with elevation less than equals to t is submerged or reachable. You can swim from a square to another 4 direction adjacent squares if and only if the elevation of both squares individually are at most t. You can swim infinite distance in 0 time. Okay, you can. I hope I have someone to explain question. You can swim infinite distance in 0 distance. Of course, you must stay within the boundaries of the grid during the swim. Let's try to return the minimum time until you can reach the bottom. At time 0, you are on grid location 0, 0. You will not go anywhere else because 4 direction adjacent neighbors have higher elevation than t equals to 0. You cannot reach point 1, 1 until times 3. When the depth of the water is 3, we can swim anywhere inside the grid. So the answer will be, the minimum answer will be, I guess, this n-1 grid, I guess, minimum. Okay, so maximum in this path is the answer. So I think we need to find the shortest distance with, then our answer will be the maximum in that distance. Okay, like 1 2 3 4 5 5. Okay. Then after 5 we need to wait on 5 until it becomes 16. Eventually when it becomes 16, then we can go anywhere below 16. I mean, there is, as they say, where, yes, you can swim infinite distance in 0 time. So of course when we are on 16 and our other cells are below 16, we can swim anywhere. I mean, yes, we can swim below 16 anywhere in unit time, in 0 time actually. So our answer will be 16. So we need to wait here. Okay, our distance will be cell node value. Great. So we can use, of course, we can use BFS Dijkstra. So let's see the constraints. Grid. Okay. N equals to 50. 50 is okay, I guess. We are able to do any algo. Each value is linear. Okay, this is every value will do. Oh, I just wake up. So, oh, we don't need to. So, first find what we have to find. So in this, we need to find the minimum time to reach cell n-1, n-1. Okay, whatever you want to say. Oh, from 0, 0. Then we should write some lines that help us to go. You can swim infinite distance in 0 time. If and only if. Okay, these lines are important. Instead of u, we can do v. We can swim from a square to another 4 dimension squares. Of course, we can do it. If and only if the elevation of both squares individually at most t. Most t. What is t? Start running, the water gradually rises over time. T time. Okay, it's just that. what is T is basically the minimum neighbor node, है ना? T is basically the minimum neighbor node. Okay. And anything, are we missing on anything? Meaning any cell elevated less than equals to T, some or reachable. We can go reachable. Okay, we can add one line also. No. Here we have. We can swim infinite distance in 0 time. We can add something like T. Okay. This is kind of, we can say, given things to us. So we can mention this given. Okay, so our approach will be, I guess that so to apply AtCoder, what we need min heap. We need min heap here. Yes, we need min heap because the distance is not same. If distance is same, then we can do with q only. We don't need Parthik, but okay. We need min heap, and then push min heap. We need to push 0, 0 cell, and we need also not visited. We don't need visited. We need distance, I guess. Of course, we need distance, and of course, we will do distance 0. Of course, 0, 0 equals to 0. Not no cube. Minimum time to no. It will be grid. Why this is gray? I don't like that. Do anyone know how to? Okay, no. What are you doing? I don't want this. Okay, we can't do anything. I don't think so. We can do anything. Oh, okay. Okay, but we now are gonna try this. Okay, so within these things, and we can go on 4 directions. So we will need directions. This will go for row. There is a simple trick to so that we can go anywhere. I will do. So I will just no need. DC these two will help us to move 4 direction adjacent sides. Then we enter in a while loop until q become empty. Okay, until q become empty, we are in a while. First we get the current node and current distance. Then we try to we get the distance and current node. Then we do a if under, we will perform boundary checks. So better we write boundary checks and end. I think we have to push in a queue, but for the distance we need to push the minimum of all. So I need pen paper. Wait, I'll try to do this. We are on, suppose we are on parent node, which is 0, and we have adjacent nodes 1, 23, 24, and we will choose minimum from these 3 nodes. That will be 1. That will be 1. Now the question is, I mean, if all nodes are, if any node which is minimum, okay, I think, do we need to mention, it's actually 16. Okay, I'm thinking when we are on 16, suppose we are on 16, then our again, we are on 16, then our neighbor nodes will be 5, 15, 20. Now 5 is smaller than 16, then it will choose 5. So in that case, I think, no, wait, yes, in that case I think we need to maintain a visited array. Otherwise 16 will go to 5 again, and 5 will choose 4 to 3, 2, 1, and 0. We will again on 0. Or we can do another thing. We are on 16, 5 is visited, we can go on 15 or 20. We will choose minimum from 15 to 20, 15 and 20. So we will store minimum, and then okay. So of course we need to maintain a visited array also. Visited array, and of course we need to initialize 0, as visited. Okay, we visited that. 5 is not an option. 5 is not an option because of course we are not handling parent. You know what I'm going to say. Okay, so the thing is, now we check the boundaries. Now what? How do we know the neighbor? I mean, how we are going to push? If it's a priority queue, then it will push 15, right? Of course 15 will be first. 15 will be, so I think we can store answer from here only. First our answer will be greater 0, comma 0. If we do perform a boundary check and one neighbor or new distance, okay, we can write in this if neighbor distance is less than node, suppose, then answer will be C. If it's more than node, then answer will become and we are neighbor node distance. Okay, and of course that we do the things like queue में push करना, neighbor nodes visited and distance and all these things. Visited dist A and C. Okay, we don't need this actually. We can perform distance of new row and new column. Distance of new row and new column will be if it's more, the distance will be neighbor distance. Otherwise distance will be division. We don't need to update that distance. Okay, but the thing is, if distance is less, then also we need to put in queue now. So this line should be not here. This line should be here, I guess. Then it will work fine, I guess. And we can eventually check if our node is last node, which is nothing but n-1, n-1 of, if our node is n-1, n-1, then what then just we can return distance, our distance we got. Okay, and if we can't reach, return the minimum until the bottom. Okay, we had something at least. If we okay, I will say the okay, let's try to run on any example we take. I am just taking this example. Can't we perform here? Somehow we can draw a line here. Somehow heading bold loader. We can do code here. Okay, I will write here. Then I will shift there. So this is our array. This is our heap. First we have 0. Okay. Then we have visited, similar like this. Oh my god, actually I can generate. Give me a sec. Yes, this will do my work. Just wait. Oh my god. No, I'm using int. I don't know. Bro, come on. We need this. For our visited array. And we also need distance to be max, so we can, I mean, distance is not max. If they say the nodes will be 50, then we can take 51 now. 15 will not greater than. Come on man, no man. You can't do this with me. Okay, let's try to again. Actually, I can do here. No, this is okay. I will uncomment this. Uncomment. Visited. We have visited here and we have distance here. For visited, we need to mark 1 as visited. We have heap and distance is 1. No, distance is not 1. Distance is 0. Now, okay, no need of answer. Q get the node, current nodes are 1, 23, 24. Then we are 1, 23, 24 in a heap, and 2 will be erased. Okay. Take out the one. First of all, we need to push and mark as visited. So we need to mark them visited. Of course, we didn't apply distance. 1. 1 is here. If we are exploring, when we are exploring 0, divide. When we were exploring 0, I did something wrong. Let me see. Wait. We take the current node, which was our 0, and distance also 0. 0 is more than 0. No, 0 is not more than 0. Distance will not update it. Okay. Then we push 1, 2, 3. They are marked as visited. Then 1 will. Then we take 1. Okay. We take 1 from here. This one. Then what will happen? Current distance is 0. पानी ले कौन पानी बोतल कौन सा है किरो आठ पास ले भरली पानी का भरली गेट लाल गेट तक बाहर okay, where will we? Come on guys, I didn't eat a single bite for morning. Let me think. We are on node 1 and our distance is our distance will be infinite, I guess. Yes. Get the current node, and our current node is 1. We need to update when we are pushing the neighbor nodes. No. Achha, we are pushing the neighbor nodes marked visited and also the distance. The thing is, when we are okay, that's why I am like doing parent node this. There will be a for auto neighbor of node. Okay, so thing is, first our neighbor is 1. We do the boundary check. We need to find the minimum. Okay, so we can do outside this for loop. This if this statement our this if statement will be outside from the while loop. Min node from the neighbor nodes. We can do the like minimum of min node or nbar neighbor. We can simply write neighbor. Then our min node will be neighbor node. Okay, neighbor distance. Of course, the previous is node distance, not. Wait. And if neighbor distance is, we can write here min node. In this case, our min node is 1. If 1 is more than 0, of course 1 is more than 0. So we can do min node distance, that will be 1. Others are Actually, these 51s are infinite int max. I can write in max, but it will take us so long. What will say? Long distance. I'm just 550. It also works. No need to worry. Now, we need to do fast. 23, 23. Now we look at the neighbors of 1. 23 visit, 0 visited. Other one is 2. And 2 will be here. Why? Because it's a min heap. You can write here, min heap. Then we can mark as visited. We will mark as visited, and we will try to explore its neighbors, which are 1 to 22, 3. Actually, we take out this node. This will be like this, like this. This will become 1. This will become 1. Okay. Then our distance will be 2. Here our distance will be 3, 4. Then 5. Then here 16. Now what will happen? Of course I didn't write a line. Okay. If this is not true, then distance is equals to node distance, the previous distance, not the minimum. Okay. So after this, we had 15 here. This will be 16. This will be 16. This will be 16. It's all over. Let me write. No matter what, if eventually when we push this node, I'll just stop. When we push, this will be visited, this will be visited, 5, 16, this will mark 5, 15, 16. All nodes will be visited at the end. Okay, I got this. And 3, 4, 5, 6 will be stacked in this, and at last 6, I will 3 dots here. 1, 2, 3. There will be another values. Around 24 we don't have values because 24 is the maximum number. So in the min heap, other values will become before 24. When 16 will have our answer. Answer will be 16. We can simply copy this, Control X, V. So this is how we can do this question. Okay. And now the thing is, we just need to code this thing up. I'm not going to use these fingers on keyboard. So can I pause? Let me make a window for you. How to edit? Into black. Are you able to see subscribe? Just to subscribe. Into text will be can't I just write the file text? We need text. We will write wait. Okay, we can write wait. We can choose any font. Something cool. Okay. Wait. 1, 2, 3. Let me eat. Done. Can't we do edit? No. So somehow I can mute if I can.
So this guy asked, whose devil fruit would you rather have? Pika stone fruit, or Avalo peas rose island fruit. Now, both of these devil fruits share a lot of similarities. They allow the user to merge with their environment and turn the battlefield into a weapon by manipulating the terrain on a massive scale. And they also share the same weakness. Once their true body is located, they're vulnerable. But it's obvious that one devil fruit is much better than the other. With Pika's stone fruit, he's limited to stone and rock-based environments, while Pizarro has the luxury of manipulating an entire island terrain as he sees fit. Pizarro's devil fruit is essentially the upgraded version of Pika's, and while Pika's might be more practical in smaller scale battles, Pizarro's has a massive edge in large scale fights. Just think about how broken this devil fruit would be on an island like Elbaf. So this guy asked, whose devil fruit would you...
Did you know that Muzan's legendary entrance into the Ubuyashiki mansion never actually happened like that in the manga? Let me explain. In the original manga, the scene is surprisingly simple. It's just a quick shot of Muzan standing in front of Kagaya. But in the anime, Ufotable completely transformed it into one of the most chilling and cinematic scenes in the whole series. Now, fans on Reddit started noticing something strange, that eerie aura surrounding Muzan as he walked in. At first, people thought it was just his presence, but one fan pointed out a really smart detail, that mist might actually be his flesh burning because of the wisteria flowers planted around the mansion. Since wisteria is deadly to demons, it makes sense that even Muzan would feel its effects. The idea is that Muzan was literally burning as he entered, but his insane regeneration allowed him to heal instantly. So while his body was being destroyed by the wisteria poison, he was also constantly repairing himself at the same time. Even though this burning effect isn't mentioned in the manga, Ufotable really did a great job in this scene.
Hope you enjoy your date. Thank you. Oh, okay. Let's see. What do we got?
क्या आप जानते हो नारुतो एनिमे के हर एक कैरेक्टर को उनके एक यूनिक जुत्सु से जाना जाता है, जिनमें से कुछ टेक्निक को तो लोगों ने रियल लाइफ में भी यूज करके रखा है। जिस वीडियो का ये सेकंड पार्ट है। नंबर 1 पर है वाटर वॉल जुत्सु। इस वाटर रिलीज टेक्निक को स्पेशली अपना तोबिरामा सेंजू एंड किसा में यूज करते हैं, और मैं तुम्हें जिस जुत्सु की वीडियो दिखाने वाला हूँ उसे तो तुम रियल लाइफ में भी यूज कर सकते हो। नंबर 2 पर है गेंजुत्सु, जिसका नाम सुनते ही तुम्हारे मन में इटाची उचिया आ गया होगा, क्योंकि इसे ही तो लोग गॉड ऑफ गेंजुत्सु कहते हैं। और अब तुम्हारी बारी है इटाची के गेंजुत्सु में फंसने की, तो देखो। नंबर 3 पर है शैडो क्लोन जुत्सु, जो अपने नारुतो उजुमाकी का एक सिग्नेचर मूव बन गया है, और नारुतो के इस जुत्सु को पूरी दुनिया में सिर्फ एक ही यूज कर सकता है, और वो है बिल्ला उजुमाकी। Shadow Clone Jutsu!
Can I get a large coffee, please?
कैरी भाई, हाँ जी, ये पीछे जो जाने पहचाने चेहरे दिखाई दे रहे हैं, मेरे को तो कोई पहचान में नहीं आ रहा। इसको तो मैं बिल्कुल नहीं जानता। क्या बात करते हो? कौन है ये? कौन है ये आदमी? गौर से देखिए। कौन है? ये तो शक्ल नहीं दिखाता था अपनी। ये अज्जू भाई बैठे इधर। कौन अज्जू भाई? 3, 2, 1। यार ये तो तुम्हारा फोर्ट है, इसमें तो तुम्हें जीत जाना चाहिए था ना। क्यों नहीं जीत पा रहे? बोलना अब। कह रहा सॉफ्टवेयर नहीं है भाई साइड में देखने के लिए। कैरी भाई, हाँ जी, ये पीछे जो जाने पहचाने चेहरे दिखाई दे रहे हैं, मेरे को तो कोई पहचान में नहीं आ रहा। इसको तो मैं बिल्कुल नहीं जानता। क्या बात करते हो? कौन है ये? कौन है ये आदमी? गौर से देखिए। कौन है? ये तो शक्ल नहीं दिखाता था अपनी। ये अज्जू भाई बैठे इधर। कौन अज्जू भाई? 3, 2, 1। यार ये तो तुम्हारा फोर्ट है, इसमें तो तुम्हें जीत जाना चाहिए था ना। क्यों नहीं जीत पा रहे? बोलना अब। कह रहा सॉफ्टवेयर नहीं है भाई साइड में देखने के लिए। कैरी भाई, हाँ जी, ये पीछे जो जाने पहचाने चेहरे दिखाई दे रहे हैं।
Hello, we are back. Let's get into the problem and just finish this thing up. I don't know, I'm having itching on my head. Okay. Sorry. What we need a main heap, distance array, visited array. For main heap, priority PQ. In particular, we just need pairs. We need pairs actually. So we can have pairs. Then we have vector with pairs. Then we have gray, GREATER with pair. This, pair. I think it's okay. PQ. And then we can simply PQ dot push 0,0. Grid dot size. Then we have vector int. हाँ जी no. We have to set it. Yes. Okay. बिल्कुल किंगे ओ होंगे ओके सही सलाह क्या इतना तो
पकला तो कोनी पकते जे ना बड़ा पहले पक्केला पर निकळायला पाहता जेवढे पकते जी वो काम करत हो तई काम करते ना वो हल्का स्पेस से हो जाता
अरे रे रे विजिट इट
मन्नू दे
हाँ नाट जी
गिट्टे में ना बड़ा पूरा चिट्टा दूध लायला पक्का सब कौन से पकले तो ये ले खाला रे पकले ले आए पकले मैं वो कल में हुआ चुट्टे बहुत फेस्ट जड़ा ना लड़के बेली मैं और ए मामा पर दिया साथ दे मैं पत्ते मो कर इतना चुट्टे मार देते अब ना मैं रोटी दे दो
we have two things for row and column.
ये चीज़ बढ़िया है जिम्मेदारी ना वाले गंदी ये तो मैं हमारे टाइम से मैं हाँ पतली सी ये गंदी थी आप मेरे माटी
ना ना मम्मी पढ़ो दी हमने PQ कोई अच्छी बात से दबा PQ dot top dot front by front. Of course, we have two elements. We can simply go down and create another one which will be called second. Then we have called then PQ dot pop. I just the thing is, I am thinking, do we need to put the distance along with priority queue? Because no, I guess no, I don't think so. Huh? I don't think so. What do you think? Let's try. Int dr we have -1 0, we have int column for column, it will be, man, come on, 0 -1 my god. Okay, So our decisions are ready. We can simply run a loop from 1 to 4. It will run 4 times. It will I plus plus. Then we can calculate our new row, which will be row plus dri. Similarly, we can find our new column, which will be current column plus dci. And in this, we will go in 4 directions. This will have to go in 4 directions, and we need to do a boundary check first of all. If nr new row is bigger than or equals to 0, then it's fine. Of course, if nr is smaller than n, then it's also fine. And same thing will apply. Oh my god, oh my god. I know I did this. New column equals to 0, it will find I didn't copy that. This is fine. And if not, it's it. Oh my god. And we can simply set with if new row, new column is not equals to 1. I mean, it's not visited now. Or we can simply say equals to 0. You know what we can actually do? Just leave it there. Now, we did the boundary check. We need to push the thing, whether it will be I think first we need to check the distance. If distance of new column is less, suppose it's less, I means if distance of new row and new column is less, when our new row column will be 2, 2's distance is 51. Is 51 less than? No. If 50 is no, then oh sorry. If no, then we can do this thing with if less than. We need to find the min node. So distancing will become later, I guess. है ना? So we will do the pq.push. What will be pushing? We are nr nc, and we can simply mark it as visited. Now this thing is okay. Now we need to find the min node. Min node equals to minimum of. Okay. If it's in the boundary and not visited, the minimum node will be. Oh my god. Min node, or what is min node then? Okay, we will do that thing. Min node also min node n grid nr nc min node. Actually, we can take it int max. This is our min node. The distance array. This is the current distance. This is the current distance. If min node's value, suppose we are on, you can't see in my pen. If we are on, suppose here, min node values, if we are on 16, our min node will be 15, and our min node is value is less than the previous, means distance and minus no row previous one. Min node value is this, is less, then we don't need to do anything, I guess. No, that would be okay. Then we have distance, new row, new column will be copied from previous, because previous means is larger one. Okay, if this is not true, if min node value is equals or greater than this thing, previous value is greater, and that we can take the value for this, then we can do this. This will be like, wait, this is greater, we can take min node and put, sorry, where is min node? Int max, min node max or grid, of course, take the value from here. We need to do this thing after loop, then will work. I hope this will do our thing, and we can return from here if, sorry, row to and call equals to n minus 1. We can simply, return, we need to write the return keyword distance of 0, not 0, n minus 1 and n minus 1, and our code will never reach here. Let's see. Okay, so it is saying priority queue declaration is wrong. Priority queue, how we make a priority queue? Bare intent. I saw one tutorial in that he read like this. It's still getting an error. We need to see how to write. Oh, come on, our first line is wrong. Why error? This is in a template you misplaced. Oh no. Where do I misplaced? One here. We do not write here. Now will it work? Will it? Visited n comma 0. Yes. Okay. I'm so sorry. I'm so sorry. This will be okay, I guess. Friend pair. What did you say? No member name friend. Oh my god, first. What the fuck, man? I don't actually in a mood to take another. Node MIN NODE. Okay. Got it. Sorry for the silly mistakes. Okay. We have no option to put. So we are saying I need to put in the if statement because that will give us error, and we need to format this. No way, bro. I don't end error. Overflows, of course. Wow. Come on. Fuck. What the fuck I'm doing? Come on, actually, at least we get answer. 20. Are you crazy, man? How are we getting 20? 16? We need this thing 6. We will go from here 20. We get 20 instead of 15 here, huh? This is what you want to say? This is you want to say? Here our answer is 3. Okay, let me see our distance here. We print, but we didn't have. Now let me print. Fat. 4 and I goes to 0. I plus. The value will be returned from there. This will not. Don't tell me this shit. What do you mean? For and I is What? We need to comment out this thing. Now look, 1, 2, 3, 4, 5, 16. Then there is 21, 16, 20, 20. If the value is less, then it is doing something crazy. If min node value is less, I will do this here. Then $16 still. Let's try to find the min node. Let's check our min nodes then. What is happening with our min nodes? And also we can do indel and line. Min and notice I write one as extra. 1, 2, 3. So 24, 1 to 8. Everything is written. That's why I'm just not want to write here. Now what? Now what? We have to do this thing. We can't do this thing above. We have to write above, I guess. But how will do the boundary check then? Let's say we did the boundary check. We did the boundary check. And then think. 15, 16, 11, 6. Okay. And description 5. No, we can't reach 5. 15, though how 15 is. Min is 24, not 1. What the fuck, man? This is wrong. You know what we need to check? We need to check our row and call values every time. This is not good. This is not good. This should not be explored. The thing is, they should not be explored because they are less. So how they are explode? I didn't get that. How? Great. Row call. This should not. Just furious about that. Okay. 0, 1, 2, 3. 0, 1, 2, 3, 4, 10, 24 instead of 5. These 3, 2, 3, 4, and 4 goes. And after 5, these. Oh my god, this is wrong. This is completely wrong. 2, 3, 4. 24, 23, 21, 22, 5, 12. Oh, come on, man. You can't do this. It's a mean heap. It's a mean heap top value. How it could be? The value is more than C and C, and this is okay, this is okay. If you can simply write not if not visited. Okay, I want to write this here. This is okay. P and C. This is okay. Then you visit it. Min. We are just saying one R and C. Okay. Okay. And I get it. What's the thing? It's particularly sorting the things according to the index, not the values. That's why we are getting this thing. So what? So we need a no way, man. I got it. What we are doing wrong? I got it. So we need to take distance along with our priority queue. So I'm not going to take the pair. I am going to take the vector. Okay, so here we need to take the vector and place everywhere. Vector. This thing is okay. This thing is okay. Okay. This thing okay. This thing is not okay. Vector. int v pq dot pop no, no. Also we need one more thing, that is int d for distance. Now proteq dot top, and at this distance we know we have 3 indexes of v0 will be this, v1 will be this, v2 will be this. Now we are good to go. So the thing is, when we are doing this, now we have distance in our property q. Distance will be 0 when it will explore. New hours distance will be 1, which is actually we can put the distance values. Distance are actually the values. So we can simply take the distance of new row and column and push along with this thing. Okay, so it will be simply sorted according to that thing. Now I just want to check something. Hopefully it works. Of course it works. Yes. Now I want to, oh my god, why? 1 2 3 4 1 2 3 4 5 16, because I don't get it why Parthik use. We didn't change the distance. Why put distance here? They should be great. They should be great. 0 1 2 3 4 0 1 2 3 4 5 16 15 14 13 1 12 10 11 10 9 8 7 6. Look, 5 16 16 16 16 16 16. Bro, told you na, we will do this. I told you, brother. I told you. So we can simply run and it should be fine, I guess. It should be fine. And hopefully it runs. And oh man, come on, man, come on. This will be an edge case, I guess. No way. What? That's why I didn't. What do you want to see? 7 3, actually 3 2, sorry, 7 2. Let me take this here. 7 2, nice. 4, nice. 6, nice. You can go 6, nice. 0 1, then 10 9, then 10, then 15. Shouldn't be answers. Oh, this 9 expedition. Okay. How my answer is 9 then? We didn't get any. Okay. Why? Because we exit early. Of course, yeah, come on. We need to check the distance heading this, so we can't exit early. Here, let me check. Whoa, 1 2 3 4 1 2 3 4 1 2 3 4 7 7 7 7 7 7 7 7 7 7 is great. Okay. I can think that much. 7, this value is 7, this value is 7. No need to go here. First of all, 2 4 wait, 7 6 7 7 7 9 10 15 1 2 3 4 1 2 3 4 10. But what? I got it. Let me redo the things. Zero 6 7 2 4 6 0 1 7 2 4 6 0 1 9 10. Then this goes up. Okay, I got it. What is happening? Then it go up instead of down, which is okay. That is okay. Then we go 3 8 3 5 11 15 about 12 goes as 13, then 14, then 15. Eventually it goes 15. So when the things got out of hands, okay, if so you are saying when you go like this, how this will become 7? I don't get this thing. Why you need to become 7? This will be answer 7 7 7 7 7 7 9 10 10 10 10 10 11 12 13 14 15. But we can't go direct 13. So this is 15. Min node minimum width. Okay. If 7 and 11 is there, then how 7 could possibly change? Oh, I need to find the greater value, greater one. Minimum of all. We should print num with distance. This is a num, and we can say this is the distance. D. This will be okay. So now we are printing. Okay. We need a little space. Haha, this much little. Give you all that much. 7 2 0 1 9 10 8 3 15. So distance is 15 at the end. When so what is wait, distance is 15 when n and row and columns. What's the issue? 9. Okay, my bad. This should be D. No, this is wrong. Wow. 6. But we can store max of D. Our answer, we can initialize answer here, int answer. Okay. We pop and answer is max of answer. Yeah, D. Simple. Answer. Okay. Choldina, we will got this. But we are here. Come on. Who are these people? Distant set. Oh, come on, man. Come on. They all are answers. I got it. That's just a little slow, but we got it now. Hard question. How many time can we get? It actually took 1 hour. Oh. Are we visible? So wait, man, wait. Am I visible all out the stream or not? I don't know. If my screen is not visible throughout the stream, then sorry guys. I'm really sorry. But I can't help it. Wait. No. I think we were visible. We are visible. But we also take the lunch break now. So we write the hard question in 40 minutes. Not bad, I guess. 40 minutes are good. Should we ask from ChatGPT? Is it good or not? Are we good or not? I know we are good. I just see the syntax. Although I didn't use that. If I am able to solve graph hard problem in 40 minutes, am I good? And in which tier I am in? But let's make it realistic so you can benchmark yourself properly. Okay, LeetCode hard. What hard usually means: complex data structure, diastra, variation, union, logic, BFF statements, algorithm thinking, pattern recognitions. I once tried Div2 contest. Okay, that was nightmare for me. I was not able to do even one question. If you can solve LeetCode hard or Codeforces due to the graph problems in 40 minutes, you're already above average. Definitely try to possibly touch Taiwan depending on consistency. Oh, come on, struggle in basics, so struggle. Can solve medium hard graph problems in 1 hour. Okay, I think the problem I was solving on Codeforces is due to contest that was not from the pattern I sees, I guess. Yes, that's why I was not able to do. But oh come on, I just you know what? Yesterday we had contest. I didn't participate because I thought I was not able to do that. I will do virtual contest. We should do. Let's try. I will live stream if I do. Solve 3 to 4 hard graph problems in a row. Come on, man. I'm not going to do this. So I think that's it for today. Let me put a beautiful screen so you can subscribe to us if you want. Come on. I am planning to do what I'm saying. I'm planning to upload the videos of what we call aptitude quant basically. So when first time I solved the hard problem, it took me around 2.5 and 3 hours, and that day I was very happy. I can't express, but that day I think we should go. Bye bye guys. I hope you